Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to talk about Unit 4, Lesson 4, which is all about slopes. This is a topic that has been drilled many times, 6th grade, 7th grade, 8th grade, Algebra 1, Geometry, and you're going to get it again in Algebra 2. This is something that you should know already. The big difference, though, between what you did in Algebra and what you're supposed to be learning in Geometry is the idea of parallel and perpendicular. So we're going to wade through these first two ideas, but then the real standard, the geometric standard, is down here in these two. You're supposed to be able to use and identify parallel and perpendicular lines. Let's begin with a quick definition of slope. It is the lay of the line on the coordinate plane. We look at the line on the coordinate plane. Slope tells us how to draw the line. It's written as a rational number where the vertical component, the numerator, is the rise, and the horizontal component, the denominator, is the run. So we go rise over run, and we come over here, we just count. We're up 2 units, and we're over 3 units. So we say that the slope is 2/3. We can determine the slopes of lines by just counting over here. Now look here, we're down 4 and over 1. So this line here is actually a negative drop and a positive run. This slope is -4 over 1, which we say is -4. What I say to my students is pretend that you're standing on the line. If you're standing on the line and you walk from left to right across the graph and you go downhill, that's a negative slope. Okay? But if you stand on the graph and you walk from left to right and you go up the hill, we say that's a positive slope. Okay? So this one, we're counting up 3. That's 3 units up, 3 units over. So 3 over 3 is 1. And here, again, we're standing on the line. We're going downhill. So this is a negative slope. All right, and we're down 1, 2, 3, 4, 5 units, and we are right 1, 2, 3, 4, 5, 6. Whoa, I missed. We're down 4 units and right 5 units. Well, that was just disastrous right there. Let's do that again. All right. If I was going to take the time to edit that, I would edit it out. Down 4, right 5. So -4 plus 5, we have -4/5. Right, make sure your answers agree with the problems. You're going to know if you're wrong. If you're expecting the slope to be negative and you give me a positive answer, then you should know that you're wrong. Slopes is one of those ideas where a wrong answer can communicate a lot to you if you're just paying attention. Now, visually counting the slopes is one thing, but what we actually want to be doing is calculating the slopes. Slope is a change. Change is a subtraction. If you think about growth, right? If I'm 6 feet 2 inches and in the next year I grow and now I'm 6'3", then my change in height would be 1 inch. Or if I go to the store and I buy something that costs $1.50 and I give them $2, then I'm going to get back 50 cents in change. All right, this is all subtraction. So slope is all about change. Change is all about subtraction. All right, so we're subtracting y values over x values. So we go y2 minus y1 over x2 minus x1. My A point has the coordinates -4, 3. My B point has the coordinates -1, 5. So, now the way I'm going to do this is I'm going to pretend we're on the graph and we're walking. Okay? So this is going to be point number 1 and this is going to be point number 2. All right? So point number 2 is coordinates is 5, -1, or -1, 5. Point number 1 is -4, 3. So we're going 5 minus 3 over -1 minus -4. Notice that I've taken the time to put minus a negative in there. Okay, this is important. We know it's positive, but we're reminding ourselves that we're subtracting. So 5 minus 3 is 2, and -1 plus 4 is 3. So my slope is 2/3. Now, if I were to do this the other way around, if I were to do it this way and go y1 minus y2 over x1 minus x2, look at the change. That would be 3 minus 5 over negative 4 minus negative 1. The difference is that I would be negative 2 on top and negative 3 on the bottom, which I then have to transform to 2/3. So if you take care and you do the second point first, your answer, at least for positive slopes, will be positive every time as we go from left to right across the graph. Otherwise, you're going to end up with like negative over negative. You have to change it to a positive. Both are correct, all right? Both are correct. Okay, we're calculating the slope here, so we go 7 minus 3 over negative 4 minus negative 3. So this is going to be 7 minus 3 is 4, and negative 4 plus 3 is negative 1. So my slope is negative 4. Let's do this one. First point is negative 6, 2. And the second one is negative 3, 5. Okay, so we go 5 minus 2 over negative 3 minus negative 6. This is 3 over 3, which is 1. And I'll leave the last one to your own device there. All right, we're looking at horizontal and vertical slopes here. When I take this first first one into consideration here, we've got the points 2, 3, and 7, 3. So we do the slope. We'll go 3 minus 3 over, that's 3 minus 3, 7 minus 2. Okay, so 0 over 5. Horizontal lines have what we call no slope. All right, if you stand on the line and you walk from left to right, it's perfectly flat. The vertical line is the opposite case. Here, the point A has coordinates 5, 1. And point B has coordinates 5, 7. Notice the difference. In the horizontal line, the y coordinates are the same. In the vertical line, the x coordinates are the same. So y goes 7 minus 1 over 5 minus 5. This is 6 over 0, which is a problem because 6 over 0 is not 0, and that's what a bunch of people want to do. This is not 0. Okay, it's actually undefined. All right. Vertical lines have no slope. The only individual who can move up it is Spider-Man. So if you're not Spider-Man, you are not walking along this line at all. So no slope, horizontal, undefined slope, vertical. All right, let's talk about parallel real quick. So what we've done is we've drawn line AB and then placed a point and then drawn a parallel line through it. So we use GeoGebra to do this. So there's a parallel line through CD. Let's look at the slope of A. We're up 1 and we're over 8. So I'm just doing this by observation. You might have to calculate it, but up 1 and over 8. And let's do the same thing for the line through C. That's up 1 unit and over 2, 4, 6. I find an intersection here at 8. So this is 1 over 8 as well. So we might observe that with the two parallel lines here, that the slope appears to be the same. This, of course, is just a conjecture. It's not a proof, although it does happen to be true, and we're going to take it as true for the purposes of moving along in class. So the slopes of parallel lines are the same. They're equal. If I look at perpendicular slopes, here I have line AB, which has a slope of up 2 and right 3. So the slope of AB is 2/3. The line through A, this should be A. Oh boy, that's even worse. How about this? There we go. The line through A has a slope of down 3, so that's negative 3 units down, and then 2 units over. So that's going to be negative 3/2. All right. So if I look at these, we might say that one's positive and one's negative, and that makes them opposite. Give me just a second here. The pin's acting up. So we'd say these are opposites. All right. And then we might also notice that the 1 is 2/3 and it's being flipped, so 2/3 becomes 3/2. That's called a reciprocal. So perpendicular lines have opposite reciprocal slopes. Another interesting thing is that if I multiply those two slopes together, like this, they actually cancel each other out. The 3's and the 2's, they all cancel each other out. And the result is -1. The way you prove it algebraically that two lines are perpendicular is that you multiply their slopes together, and if the result is -1, then the slopes are perpendicular. All right, let's practice. We want to find the slope of AB here. So let's get the ordered pairs. A has, well, let's see, B has the coordinates 2, 0, and A has the coordinates 14, 4. 14, 4. So the slope is going to be 4 minus 0 over 14 minus 2. This is 4 over 12, or 1/3. So the slope is 1/3. Parallel slopes are the same. The way I write parallel slopes is I write the two vertical bars and then the letter M. So this is parallel slope. It's the same. Perpendicular slope, this is the symbol for perpendicular. So perpendicular slope is equal to the negative reciprocal, or the opposite reciprocal. This is positive, so this is negative, and -3 over 1 is just -3. Okay, to do this problem, we're trying to identify lines that are parallel, perpendicular, or neither. All right, so we need the slopes of each of these. So we start with the top here. Let's go 2 minus a -8 over 8 minus 3. So this is 10 over 5. The slope is 2. And then the second one is -3 minus 1 over 7 minus 9. That's -4 over -2, which is 2. And then EF is going to be 8 minus 10 over 5 minus -1, and that's going to be -2 over 6, which is -1/3. And the last one is -3 minus a -6 over 22 minus 21. This is -3 plus 6, which is 3 over 22 minus 21, which is 1. So let's look at these different lines here. And I'm going to put my pen away again. All right, let's find some slopes that are parallel. Well, AB and CD are both 2. So AB is parallel to CD. We also know that -1/3 times 3 over 1 is -1. So EF is perpendicular to GH. But the other sets have no relationship. AB to EF is neither. AB to GH is neither. CD to EF is neither. CD to GH is neither. Okay. Finally, this is just a basic calculation one. So we're going to find the slope of these lines. So there's no graph this time. 21 minus 7 over -3 minus a -12. 21 minus 7 is 14. -3 plus 12 is 9. So 14/9 is the slope. A parallel slope would be 14/9, and a perpendicular slope would be -9/14. All right, there you go. See you in class tomorrow.